A Megger is a portable electrical insulation tester employed to measure the resistance of insulation materials in various electrical applications. Firstly, meggers are essential for testing insulation resistance in electrical circuits and components. They verify the health of insulation in wiring, cables, transformers, motors, and other electrical equipment. Secondly, they are used in high-voltage systems like transmission lines and substations. Meggers apply a high voltage to the insulation material and measure the current flowing through it. The higher the current, the lower the insulation resistance, indicating potential problems. Meggers are also used for detecting ground faults. In electrical systems, meggers help locate faults where insulation has degraded, allowing current to leak to ground. For appliance safety, they test the integrity of insulation, reducing the risk of electrical shocks and fires. Meggers are connected between the conductor and ground. A high current indicates a fault in the insulation. They are also important in commissioning and maintenance for new installations. Meggers verify the quality of insulation in newly installed electrical systems before they are energized. Also, they are part of routine maintenance programs to monitor insulation health and identify potential issues before they become major problems. Electrical equipment is regularly tested to ensure that the insulation is in good condition. Meggers are important in troubleshooting where electrical faults are concerned. Meggers help identify electrical faults caused by insulation failure. They are used to test the insulation resistance of motor windings to diagnose potential problems. Meggers isolate the suspected faulty component and measure its insulation resistance to pinpoint the location of the issue. When using a Megger, ensure proper safety precautions, including using insulated gloves and grounding equipment. Disconnect the equipment from power before testing. Discharge the Megger thoroughly before and after use to avoid electrical shocks. Set the Megger to the appropriate voltage and resistance range for the application. Hold the Megger probes firmly against the test points and maintain a steady contact. Interpret the results according to the manufacturer's specifications. Insulation resistance testing with a Megger is a crucial diagnostic procedure that assesses the condition of electrical insulation. This test involves applying a direct current (DC) voltage to the insulation and measuring the resulting current flow. The insulation resistance is then calculated using Ohm's law. A high insulation resistance indicates good insulation quality, while a low resistance suggests potential insulation degradation or faults. The test is essential for preventing electrical breakdowns, ensuring equipment safety, and maintaining the reliability of electrical systems. Factors such as temperature, humidity, and the presence of contaminants can influence insulation resistance readings, making it important to consider these factors during testing and interpretation. In electrical systems, ground faults occur when an unintended electrical connection is established between a live conductor and ground. This can result from insulation failure, physical damage, or environmental factors. Ground faults pose significant safety hazards, including the risk of electric shock and fire. Ground fault detection involves identifying and locating these unintended connections to ground. Methods for ground fault detection include using ground fault circuit interrupters, GFCIs, which quickly disconnect power upon detecting a ground fault, and insulation resistance testing using Meggers to identify areas with degraded insulation. Prompt detection and correction of ground faults are crucial for maintaining electrical safety and preventing equipment damage. Meggers can also be used for preventative maintenance. Preventative maintenance for electrical equipment involves regularly scheduled inspections, tests, and servicing to ensure reliable operation and prevent unexpected failures. This proactive approach includes visual inspections for signs of wear or damage, insulation resistance testing to assess the condition of insulation, and cleaning and lubrication of moving parts. Thermographic surveys can identify hotspots indicative of potential problems, while vibration analysis can detect mechanical issues. By implementing a comprehensive preventative maintenance program, businesses can reduce downtime, extend equipment lifespan, and improve overall safety. The periodic testing of electrical equipment is a critical aspect of ensuring safety and reliability. Regular testing helps identify potential problems before they escalate into major failures. Testing methods vary depending on the type of equipment, but often include visual inspections, insulation resistance testing, and functional tests. Visual inspections can reveal obvious signs of damage or wear, while insulation resistance testing assesses the integrity of insulation materials. Functional tests verify that the equipment operates as intended under various conditions. By adhering to a schedule of periodic testing, organizations can maintain the performance of their electrical systems, minimize downtime, and reduce the risk of accidents. When troubleshooting electrical faults, a systematic approach is essential for efficient problem solving. This process typically begins with gathering information about the fault, including when it occurs, what equipment is affected, and any recent changes or events. Next, visual inspections can help identify obvious signs of damage or loose connections. Testing equipment such as multimeters, clamp meters, and insulation testers are then used to measure voltage, current, and resistance at various points in the circuit. By analyzing these measurements and comparing them to expected values, the location and cause of the fault can be determined. Once the fault is identified, appropriate repairs can be made, followed by testing to ensure the problem has been resolved. Proper safety procedures should always be followed during troubleshooting to prevent electrical shock or other hazards. Motor winding insulation is a critical component of electric motors, providing electrical isolation between the windings and the motor frame. This insulation is typically made of varnish, enamel, or other dielectric materials. Over time, motor winding insulation can degrade due to factors such as heat, vibration, moisture, and chemical contamination. Degraded insulation can lead to short circuits, ground faults, and ultimately, motor failure. Regular testing of motor winding insulation using Megger meters or other insulation testers is essential for assessing its condition and detecting potential problems before they result in costly downtime. Practical tips for using a Megger include safety precautions, proper connections, and understanding how to interpret results. Safety precautions are paramount. It is crucial to de-energize the circuit or equipment being tested to avoid electrical shock. Wear appropriate personal protective equipment, including insulated gloves and safety glasses. Ensure the Megger is properly calibrated and in good working condition. Proper connections involve connecting the Megger leads to the appropriate points in the circuit or equipment being tested. Follow the manufacturer's instructions for lead placement. Understanding how to interpret results involves recognizing that a high resistance reading indicates good insulation, while a low resistance reading suggests insulation degradation or a potential fault. Compare readings to previous tests or industry standards to assess the condition of the insulation.